This is 3.3 log functions and graphing. So we have some very important concepts for you. You're going to always start with your XY chart with the points 1, 0 and B1. So no matter what, if you're graphing a log function, you're going to have 1, 0 as your first point in your XY chart. And then B stands for whatever the base of the log is. So if you're graphing log base 2 of x, you're going to start with the point 2, 1 here. If you have log base 10 of x, you have 10, 1. If you have ln of x, you're going to have 2.721 because that base is e. So this point varies based on the log function you're graphing, but b is always the base of that log. You're going to always have a vertical asymptote at x equals 0. So that's where it starts, and that's what you're always going to have. The only time it changes is if there's a horizontal shift left or right. So if there's a horizontal shift left, you're going to have x equals negative, whatever it is, as your vertical asymptote. And if it's x plus a number, you're going to have your vertical asymptote at x equals that positive number, whatever it is. And then we want to remember our transformation rules. Inside affects the x's, and it's the opposite operation. And the outside affects the y's, and it's the same operation. So we have two graphing examples. The first one is y equals negative log 3 of x plus 2. So that negative is a reflection over the x-axis. This 3 is going to be a horizontal shrink by 1/3 because it's on the inside and we're thinking opposite operation. We're dividing by 3. So it's a horizontal shrink by 1/3. This is a vertical shift up 2. So my XY chart, because there's no number there, I know it's base 10. So the 2 points I start with are 1, 0 and 10, 1. I multiply all my y's by -1 because of the reflection, and then add 2 to them because of my vertical shift up 2. Now I have a horizontal shrink by 1/3, so all my x's get multiplied by 1/3 or divided by 3, so I end up with 1/3 and 10/3. So the points I'm plotting are 1/3, 2, and 10/3, 1. So I have 1/3, 2, and 10/3, 1. My vertical asymptote at x equals 0 because I had nothing added or subtracted, no horizontal shifts inside, and this is what my log function looks like. Here, I have log base 9 of 6 minus 3x. So the first thing I want to do is get this organized so that I know what my transformations are, because right now I have 6 minus 3x is a little bit confusing. So I want to factor within this the -3 out. So the first thing I'm going to do is rewrite it by switching these two. So I have log base 9 of -3x plus 6, and then I factor the -3 out. So now I have log base 9 of -3 times x minus 2. This becomes -2 because if I factor -3 from 6, I'm dividing 6 by -3, which leaves me with -2. And to check my work, if I have -3 times -2, I go to distribute that back. It gives me my +6. So this is what I'm working with. So I have a reflection over the y-axis because of that negative. I have a horizontal shrink by a factor of 1/3 because I have my 3. And I have a horizontal shift right 2 units because of my -2. So I'm going to multiply all my x's by -1/3. Again, you could divide by -3. It'll still give you the same answer. So my x's were 1 and 9 because I had log base 9. So 1 times -1/3 is -1/3, and 9 times -1/3 is -3. Once I have these numbers, I want to add 2 to each of them. So -1/3 plus 2 is 5/3, and -3 plus 2 is -1. So I end up plotting 5/3, 0, and -1, 1, and my log function looks like that graph right there.